Hi everyone. So today we will solve this problem, count good nodes in a binary tree. So our input is a binary tree and we have to count how many good nodes are there in this tree. So a good node X in this binary tree is 1 such that the path from root to that node X, there is no node which has a value greater than X. Okay, so if suppose this is the root node and there might be some path, okay, from R and X. There might be some path between R and X. So between this path, there should not exist any node which has a value greater than this X. Okay. So suppose the first node is 5, this is 4. Okay. If the value of this X node is 3, then this is not a good node. Why? Because if we see from path from root till this X, we have a node which has a value greater than 3, which is 5. But if the value of this X was suppose 10, in this scenario, this is a good node. Why? Because the path from root till this X, there does not exist any node which has a value greater than 10. So it will be a good node in that scenario. So let's look at this example. So in this binary tree, whatever is marked as blue, those are good nodes. Okay. So let's check them one by one. So if we check for 5, okay, the path is from 3, 3 is the root node, till 5. Does there exist any node which has a value greater than 5? This is not greater than 5. This is also not greater than 5. So yes, this is a good node. Similarly, if I check for this one, does there exist a node greater than 1? So the path is 3, 4 and 1. Does there exist any node greater than 1? Yes, there are actually two nodes. One is 3, root itself, and one is 4. So this is not a good node. So similarly, we can check for other nodes. And one thing we should notice is that for root node, it will always be a good node. So suppose root node is 5. So the path from root to this 5 will only contain this node itself. So there will not exist any node greater than 5, right? So for root node, it will always be a good node. So let's look at the solution to solve this problem. So to solve this problem, first of all, what we need is a traversal. Okay, so then only we can traverse each node and tell whether the node is good or not. Okay, that part we can do using in order or the post order traversal. And a second important point is the max node value, which we will have to remember for each recursive call. Okay, so let's try to understand what this is. So let's assume that we have a binary tree, skewed binary tree like this. Okay, so for each node, we will check if it is good node or not, and we will maintain a value max. This max will store the maximum value of node which we have seen till now in the current path. Okay. So first of all, we are at 3. So max will be 3 only. And we will maintain a count also, which will count the good nodes. So 3 is not greater than 3. So there does not exist any node greater than 3. So count will be 1. This is the root node. So it will always be true for this. Then when we go to the next node 5, the path from root till 5. Okay. So the max value is 3. That means we have seen a node with value 3 only till now, which has a max value. Okay. That only we have seen. But currently, if we see, we have a 5. So 5 will be a good node. Why? Because it is greater than max. Okay. So we will increment the count and we will update the max also. Because now this 5 will be the part of other path also. Okay. Now when we advance to 2, is 2 greater than 5? No, that is not the case. So that means this is not a good node. Okay. So we will always compare with the 5. Then again, if we move forward, we will check with 6. Is 6 greater than 5? Yes. So from 3 till 6, right now we have only seen a node which has a value 5, which is max, and with 6 getting added to this path, now we have a new max. So max will be updated and the count will also be updated. So this is what the logic is. So let's write a simple pseudocode to understand the full logic to solve this problem. So first of all, we have to do the traversal, right? So suppose this is the function solve. So first we will go to the left of the root, then we will go right of the root, and we will have a value max, correct, for each node. Then we will check if current node value, root arrow value, is greater than equal to max. That means we are checking for each node, for 5, for 2, for 1, for 6. Is the current max greater or smaller? If current value of the node is greater than or equal to the max, we can count plus plus, we can increment the count, and we can update the max, correct? So this is what will count the number of good nodes, and we will have a base condition also. If root is null, we can simply return. This is the base condition. This is good node logic, and this is traversal. So this is what we have to do. So let's look at the code and try to understand it from code perspective. All right, so this is the code. So the pseudocode I have already written earlier. So if you see, it is similar. So this is what we are doing here. We are simply traversing the binary tree. That's it. Okay, and we are maintaining the max for each call, right? And this is the main condition. So here what we are doing, we are comparing the current element with the max. Okay, so if the current element is on a particular path, max will store the maximum value of the node which we have seen till now. So if the current node is greater than or equal to the max, so we can increment the count and update the max, right? And then we will traverse the left and the right subtree. And this is the base condition. Okay, so if our root is null, so we will simply return, we don't need to do anything. And this is it. And the main function is good nodes, which will be called first. And then from here, we will call the solve function. So here we will pass the root address of the count because we have not taken it as global. So we have passed it as a argument, and the max value. So first of all, the max value will be what? It will be the value of the root node. Okay, so we are starting from 3. So what is the node which we have seen till now, and what is the maximum value? It will be 3 itself, right? So we will simply call this, then it will check if it is null or not. If it is not null, then it will check for this good condition. So for root, it will always be true. Then it will go to the left subtree and the right left subtree and the right subtree, and it will check if this is good node or not. It will check if this is good node or not. If it is good node, it will update the max. So for this node, max will get updated to 4. Then we will check for the left and the right subtree and so on. So this is it. And regarding time complexity is big of n, where n is the number of nodes in the binary tree. So we can simply check what we are doing. We are going to the left and the right subtree, or we can say we are traversing each node in this binary tree. So that's why complexity is big O of n. Okay, so I will share the link to this code. You can check it out. And yeah, thanks for watching the video. Bye. Take care.